Welcome back.
Hunter. Alright. As an object
Need a commercial
falls,
break.
it goes faster and faster. So let's draw what
Previously
that would look
on
like.
Physics Part 1.
Somewhere on your paper, draw the first second, it goes that much, but if it's going faster, the second second, it's going to go that a lot further, and the third is going to go even further. So draw an arrow, a couple arrows showing how an object travels toward the Earth. It's accelerating. So we did something like this the other day when we took paper and dropped it. Let's see if we can observe acceleration as an object falls. We'll use our paper again. So let's see what happens when we do this. I don't think we need to get up on the table this time, because paper goes pretty slow anyway. Alright.
1, 2, 3, 4, 5. 5 seconds.
Did that look like it went faster and faster?
Nah.
How about this?
Yep.
How about this?
Yep.
How about this?
Yep.
Alright, probably the only one that really demonstrated that, and even that was the last one. So what was coming out to play as I dropped those 4 papers, Brandon?
Air resistance.
Air resistance. So it turns out that as I would like you to take your pencil and draw around those arrows a lot of air molecules. We talked the other day that there was carbon dioxide, oxygen, argon, nitrogen, all kinds of air molecules around the object that's falling in free fall. So as the velocity increases, the air resistance, I'm going to write that as, so looking at this over here, as velocity increases, air resistance, fill in the blank. It's going to either increase or decrease. Put in your, see what makes sense to you. As an object is falling, my penny again, as it falls toward the Earth and accelerates, going faster and faster, what is going to happen to the air resistance on it as it goes faster and faster? As velocity increases, air resistance, fill in the blank with whether you think it goes up or down, increases or decreases. It should make sense to you as this object goes faster and faster, it's bumping against more and more molecules. So actually air resistance increases. So if you didn't put that, go back and change it. That's what happens. Because the arrow, because the object is going faster, it's bumping against air molecules in an increasing manner. So as velocity increases, air resistance increases. So get that down, because we're headed toward terminal velocity, and we're kind of thinking our way through. So as velocity increases, air resistance increases. So as air resistance increases, acceleration, blank. So another increase-decrease thought. Put in what you think. So envision the penny going faster and faster, hitting more and more molecules. Air resistance is going up. What will that increase of air resistance actually do to the acceleration? Brandon?
Well, if the air resistance is getting higher, wouldn't the acceleration be getting lower?
It does.
So it will go down.
Does. So I guess previously when I told you that acceleration to the Earth was always constant, negative 9.8 meters per second squared, that was really only, I was telling you to negate or ignore air molecules, so that what I said was true. But now, being more realistic, where do we drop things where there's no air molecules? There are not many places that we get to do that. So this is more of what we experience. As velocity increases, air resistance increases, and acceleration decreases. Acceleration will continue to decrease as long as the object hits more and more molecules, and eventually acceleration will become 0. Meters or feet per second squared. So eventually, this process, if it's in free fall long enough, eventually the air resistance will build up and build up against the acceleration. There'll be no acceleration. Does that mean the object is not moving with no acceleration? How does that work? Emily Davis, is 0 acceleration?
Good.
It just
Thank
means
you.
it's going out constantly.
Right. So I'll put that up there. Velocity is constant. All right, get all that down, because that's basically the lesson in a nutshell right there. What terminal velocity? We'll go back and define terminal velocity. Going back to the top where I need a definition, it's the max velocity an object in free fall reaches. All right, you need all that on your today's notes. So what kind of things affects the terminal velocity? What kind of things affects air resistance? So you saw this, you saw that, you saw this, and you saw that. So that's to give you some clues. What kind of things affect the terminal velocity? What?
Surface area.
All right, great. So terminal velocity is affected by surface area, and that was shown to you by the folded paper that was this way and the folded paper that was this way. This one has much more surface area to encounter those air molecules. Can you think of anything else? What about this one? Or I guess the book would be a better one. We need to do our book every day, don't we? We're in physics class.
Whoa,
right.
man.
So, terminal velocity is affected by surface area. Let's all of us do it. Stand up, drop your book. Ready? It's so loud. 5, 4, 3, 2, 1.
Drop the.
Alright.
Slowly.
Monday morning exercise, did you say?
Try to
Alright.
get my ears.
Did you toss it over here?
I did. Thank you.
Alright. Terminal velocity is affected by surface area. And what about the book? It went faster than all, even I think,
mass?
mass. And basically, not only mass, but how compact it is. So I'm going to call that mass and density.
What's mass times acceleration?
I'm sorry?
What mass times acceleration?
It's called force.
Oh, okay, that's what it is.
Alright, that'll be a mantra in a little bit, but next chapter or two. Alright, so what else? Surface area affected it, mass and density, size, which is sort of related to surface area.
And mass.
Mass I put up there with density, so is there anything else you can think of?
Well, no, like size is also related to mass.
Mass, yeah, those words are intertwined, but whichever one kind of gets the picture for you. I would kind of say shape, but shape is sort of size and mass. These words are all
Well,
their meanings overlap, so that's okay.
yeah,
Shape
certain
and,
shapes can actually pierce, like this also has to do with surface area, but they can
Yeah.
pierce through air resistance more efficiently.
Right, and orientation is like what shape is hitting the molecules first. Orientation. So if I was to ask you what kind of things affect the object's terminal, what kind of quantities, I guess these aren't quantities, what kind of characteristics affect the terminal velocity of an object, you would be speaking about these things in the way that makes sense to you. Some of those ideas overlap. So they're not real precise, but they all point to things that affect terminal velocity. So each object has its own terminal velocity. We cannot calculate the terminal velocity in this class. So we will stick with our 3 equations, but I want you to be aware that terminal velocity exists. So let's talk about a bug. Anyone seen a bug today?
Nope.
No bugs?
I seen any bugs today.
You live a sheltered life.
Bugs? True.
Right. Draw a bug somewhere
A
on your
bug?
notes.
A bug. The most annoying bugs are stink bugs. I hate them so much. Gosh.
When I say bug, I mean insect.
I like Bugs Life. That was my movie back in the day.
Bug.
It's so weird though. I was like, what is this
All right.
about?
I won't put a smile or a frown until you answer the question for the bug. When the bug has fallen and it's in free fall, it has no wings. I think all insects have wings, but this one has lost its wings. It was a birth defect. So we have a bug in free fall.
This book has a surprisingly deep backstory.
We have a bug in free fall, and he begins to accelerate toward our planet. And I
Oh,
want
wow.
to know if he has a frown or a smile on
Is he
his
an
face.
astronaut or something? Like he's coming back into orbit and he's like he's gonna make it.
He's like in a tree.
So, looking at all
or
these
that. Or he's an
characteristics
astronaut,
of
either one.
shape and density and surface area and orientation, all that, do you think that the bug will reach its terminal velocity quickly, or will it reach its terminal velocity later? You want to reach it quickly if you want to survive, because the terminal velocity will be lower if you reach it quickly. So what about the bug? How is he constructed? Will terminal velocity be met sooner or later? Any thoughts on that, Alex? Looking at his mass, his density, his size, his orientation, his shape.
Well, his mass and density are probably small. His size is small.
Right.
His shape is soft.
So really, remember we were looking at, this has a density that's not that great.
Yeah.
And then the book, I don't know if this will show up. The book has a lot of density. Yeah, the book made it down first.
Yep.
It's a Toga.
Okay.
Hit it.
Part 3.
Commercial break.